Hello and welcome to Engineers Mindset Academy. Alright, so today we'll begin the very first series on the Fourier series. Now, what is a Fourier series? A Fourier series is simply the series of sines and cosines of a given function, usually represented mathematically as f of x equal to a naught all over 2 plus summation from n equal to 1 down to infinity of an cos nx plus bn sin nx. Alright, so mathematically, this is how we represent the Fourier series, where a naught, an, and bn are simply called the Fourier constant. So for a given function, a naught can always be determined using the equation 1 all over pi integral from minus pi to pi f of x times the x. Okay, so given any function, you simply make use of this relationship to find or to calculate the Fourier constant a naught, whereas an can be solved using the relationship 1 all over pi integral from minus pi to pi f of x cos nx dx. Okay, so we simply make use of this relationship to find the Fourier constant an. And finally, bn can be solved using the relationship 1 all over pi integral from minus pi to pi f of x sin nx dx. Okay, also the interval from minus pi to pi is not a constant. If you're given a question and you have a different range or a different interval, that means you have to use the interval given to you in a question. But when an interval is not given, then simply maintain this interval from minus pi down to pi. Now let's take a simple example. Let's say we're asked to write the Fourier series of the function f of x is simply equal to x. Let's say we're asked to write the Fourier series of this function where, okay, x is between minus pi less than equal to x less than equal to pi. Okay, now the first thing to do is to what? Find their Fourier constant. So we start with a naught. A naught is equal to 1 all over pi integral from the limit in this case now is from minus pi to pi. So we still maintain that from minus pi down to pi, and we simply said f of x dx. And what is f of x? F of x is equal to x, so this is now equal to what? X times dx. Alright, so this is equal to 1 all over pi. Now you carry out your simple integration. If I integrate x, remember, this becomes x to the power of 2 all over 2. From the principle of integration, if I integrate x, I'll simply have x squared all over 2. Now you put in your limits. The limits are from minus pi down to pi. Okay, you have this. Alright, so you can also choose to factor out 1 over 2 by pulling out these 2 here. This becomes 1 all over 2 pi into x all squared from minus pi down to pi, and you have this. Okay, now you can put in your limit, upper limit minus lower limit. Therefore, a naught is equal to 1 all over 2 pi into upper limit is pi, and this is x squared, so it becomes upper limit squared. That becomes pi squared minus lower limit, and lower limit is minus pi. Now mind you, lower limit is minus pi and it is under what? Squared, so it becomes minus pi all squared, and you have this. This is now equal to 1 all over 2 pi into pi squared, okay, minus pi squared, that becomes plus pi squared, so you're left with what? Pi all squared. And this is equal to 1 all over 2 pi times pi squared minus pi squared is simply 0. You have this. Now 1 over 2 pi multiplied by 0 simply tells us that a naught is equal to 0. So you have this to be equal to 0. Alright, so that's how you find your Fourier constant a naught. Now move over to what? Looking for an. Okay, an is equal to, again, 1 all over pi integral from minus pi to pi. So we're maintaining the limit given to us from minus pi down to pi. Alright, so the limit can be different. It's not a must that it will be from minus pi to pi. But if it is not given to you, if the limit is not given, then you maintain from minus pi down to pi. All right, so a and simply states this integral of f of x cos ns ds. So what is f of x? Once again, f of x is equal to x. So in place of f of x, you have x cos nx dx. Now, this is a product integration. I have x multiplying cos nx dx, which means I'm going to be employing the principle of product integration to carry out this analysis. And what is the product integration? Integral of u dv, which means if I have two functions multiplying one another under an integral, then you simply use this is equal to uv minus integral of v du. Now, this is how to solve integration by parts or the product integration. Okay, now u is always taken as the function given to you. Whenever you're solving Fourier series problem, u is always taken as the given function, whereas dv is always taken as the Fourier function. Okay, what that means is that in this equation now, u always is going to be my f of x. And what is f of x? X. So from the integral, u will always be taken as what? X. So we have x, and dv is always going to be taken as the Fourier, okay, as the Fourier constant or the Fourier function in the integral. The Fourier function there is cos ns times the x. So this is how you pick your u and your dv. Now from the equation, integral of u dv means this integral, because u is equal to x and dv is equal to what? Cos ns. So this is simply what? This integral, that's what we're talking about. Now, how do we find v and how do we find du? Very simple. To find du simply means differentiate u. So if u is equal to x, therefore, if I differentiate u, du is simply equal to what? The x. Now, this is a simple idea. If u is equal to x, then it means that I can only differentiate u with respect to x. That is du dx. And du dx is equal to what? Remember, if I differentiate x, I'm going to have 1. So if you cross multiply the x multiplied, this is the same as saying 1 all over 1. The x multiplied by 1, du multiplied by 1. So this will give us what? That du times 1 remains du, and that's equal to the x times 1 remains what? The x. So if the power is just 1, then it means du is equal to the x. So du from here is equal to the x. And to obtain v is simply obtained by integrating dv, okay? Simply by integrating dv, that's how you find v. And what is dv? Which is this function here. So you're simply integrating cos nx dx. Now, take note, to integrate a trig function, the first thing you need to do is identify the angle. In this case now, this is integral of cos nx dx. The angle there is what? Nx. This is the angle. Now, differentiate this angle with respect to x. If I differentiate this angle, I'm going to have what? N left. If I differentiate this angle with respect to x, I will simply have n left. Use this derivative to divide the integral of the trig function. If I integrate cos, the trig function here now is cos. If I integrate cos, I'm simply going to have what? Sine. So this is going to give me sine. Then put back your angle, sine nx, divided by what? This derivative you obtained earlier, all over n. So to integrate a trig function, first of all, differentiate the angle with respect to x. Use that derivative to divide the integral of the trig function itself. It gives you what? The answer. So if I integrate cos ns ds, this is simply going to be integrating cos. I'm going to have sine nx all over, then differentiate the angle nx. I'm going to have what? N. So the integral of that function gives us sine nx all over n. That is now going to be the value of what? V. Alright, so you simply plug this into the equation. Okay, you simply plug this into the equation. This is the integration by parts formula. Integral, remember, u always is x, and dv is simply what? Cos nx dx. Now, mind you, we are carrying out this integral without the limit minus pi to pi, and without this 1 all over pi here. So, which means until we effect this limit and this constant outside, it can never be termed as what? an. So this is first of all to carry out this integral to obtain what this integral is before we can now effect this limit. All right. Now this is equal to from the formula u times v, and we say let u be x. So this is simply x times what is v? We obtain v to be this sine nx all over n. So this is sine nx all over n minus integral of v du. Again, v is equal to this sine nx all over n times du. What is du now? Remember, du is equal to the x. So this is now what? Times the x. You simply have this. Alright, so integral of x cos nx, the x is now equal to, we have x sine nx all over n. I can factor out 1 all over n here. It is common. It becomes minus 1 all over n integral of sine nx times the x. So this simply means I still have to integrate what? Sine nx all over the x. Therefore, integral of x cos nx, the x is equal to x sine nx all over n minus 1 all over n into, again, to integrate a trigonometric function, differentiate the angle, use that derivative to divide the integral of the trig function. If I differentiate the angle here is nx. If I differentiate nx, I'm going to have n. With respect to x, I'm going to have n. Now, if I integrate sine, mind you, if I integrate sine, I'm going to have minus cos. I'm going to have minus cos nx all over, then append now the derivative of the angle, which is n. Alright, so you simply have this. So keep that in mind. If I integrate sine, I'm going to have minus cos. But if I differentiate cos, I will have minus sine. Alright, keep that in mind. So we can continue over here. Alright, so integral of x cos nx dx is now equal to, we have x sine nx all over n minus, now mind you, I can factor out this n over here. It becomes 1 over n times n, which gives us 1 over n squared. Again, minus times minus from here. There's a minus sign inside this bracket. This minus multiply this minus outside here becomes plus. So this is now plus. I'll have simply cos nx all over n times n here becomes n all squared. So we are done with the integral. At this point, let us effect all the signs that makes it what? An, which is the Fourier constant. Therefore, an itself is equal to, remember, 1 all over pi integral from minus pi to pi of this function x cos nx the x. So all we are simply doing is now we are going to effect the limit in this result and also effect this constant outside. It becomes 1 all over pi multiplying through by x sine nx all over n plus cos nx all over n squared, putting the limits from minus pi down to pi. You simply have this. All right, let's continue here. So an is now equal to 1 all over pi. So I'm going to be appending the limits all together. Wherever I see x in these equations, I'll put in both my upper limits minus my lower limit. So I have x here, and in place of this x comes upper limit minus lower limit. This is now upper limit pi minus pi. Lower limit is minus pi. Okay, this multiplied by sine nx. There is x there as well. So you have sine, okay, x there becomes upper limit, which is pi, minus lower limit, okay, times n all over n. So this is for the first case. Now, we'll also redo the same thing for what? Cos nx. There is x here. In place of x, upper limit minus lower limit. So this is now plus cos, okay. In place of x, we have upper limit, which is pi, minus lower limit. Lower limit is minus pi, okay, times n all over n all squared. All right. So an is now equal to, okay, this is supposed to be like this. All right. An is now equal to 1 all over pi into, mind you, pi minus minus pi becomes pi plus pi. All right. Sine pi minus minus pi again becomes pi plus pi multiplied by n all over n plus, same thing here, cos pi minus minus pi becomes pi plus pi multiplied by n all over n all squared. So an is now equal to 1 all over pi into pi plus pi, of course, is 2 pi sine, same thing here, pi plus pi is 2 pi, so we have sine 2 pi n all over n plus cos pi plus pi also becomes 2 pi times n all over n all squared. Now, in front of a trigonometric function, pi always appears as 180 degrees. In front of a trig function, pi is always 180 degrees. This simply means that 2 pi becomes 2 times 180, and this will give us 360 degrees. So sine 2 pi simply becomes sine 360. Alright, so this is equal to 1 all over pi into 2 pi. Now sine 2 pi there becomes sine 360 n all over n plus, same thing, cos 2 pi here becomes cos 360 all over n all squared. So this implies that an is now equal to 1 all over pi into, mind you, sine 360 is 0, so it becomes 0 times 2 pi over n, so everything here automatically becomes 0. So you have 0 plus cos 360 is 1, alright, so it becomes 1 all over n all squared. Okay, so this simply implies that an is equal to, remember there's 1 over pi here, so 1 over pi multiplies 1 over n squared. This gives us 1 all over pi n squared. So the value of an for that function is simply 1 all over pi n squared. So let's put it here. An equals 1 divided by, I can take this off now. Alright, so an equals 1 divided pi n squared. Alright, so that's our second Fourier constant, an. Finally, we find the Fourier constant bn for the given function. So that's all you need to do. Whenever a problem is given to you on Fourier series, first of all, find their Fourier constant before you can now write the series. So let's look for the final Fourier constant. Okay, so not forgetting the function f of x is x. Limit c remains from minus pi to pi. So I'm going to be taking this off. Alright, so bn is equal to, remember, 1 all over pi integral from minus pi to pi. F of x is x sine nx times dx. Again, we make use of the integration by parts formula. Remember the formula, integral of u dv is equal to uv minus integral of v du. So this is the integration by parts formula. So having this formula, I said earlier, u always is the given function, dv remains the Fourier function. So u always is taken as the given function, f of x is given as x, and dv is the Fourier function under the integral, in this case now, sine nx, okay, times dx. And from the formula, it says uv minus integral of v du. So we need to find du, we need to find v. We explained this already. So du simply means differentiate u. If I differentiate u here, I'm simply going to have the x, and v is simply by what? Integrating the v, which means I have to integrate sine nx dx, because dv is equal to sine nx dx. So integral of dv simply means integral of sine nx dx. And I said to integrate a trigonometric function, remember, first of all, differentiate the angle. Nx angle, if I differentiate nx with respect to x, I'm simply going to have n. Use this derivative to divide the integral of the trig function. If I integrate sine again, if I integrate sine, I'm simply going to have minus cos, pull back your angle, nx, all over, now divide by the integral n. Simple. It's as simple as this. Okay, so let's plug this back into the formula. The formula is integral, remember, u is what? X. So it becomes x. So all we are doing is simply what? Integrating this given function without the limit, x sine nx dx, without the limit from minus pi to pi, and without this constant outside. So it becomes x sine nx times dx, and this is equal to, the formula says u times v. What is u? We said let u be x, so you have x for u times v, and v is simply minus cos nx over n, so times minus cos nx all over n, okay, minus integral of v du. Again, v remains minus cos nx all over n times du, and du is equal to dx from here, so simply times dx. You have this. So integral of x sine nx dx is now equal to, okay, let's rearrange this a little bit. It becomes minus x cos nx all over n. Again, mind you, minus here times this minus becomes plus. I can factor out 1 over n out of the integral sign since it's a constant. This becomes plus 1 all over n integral. I'm left now with cos nx times dx. So this simply shows I'm going to be integrating this function once again. Okay, so integral of x sine nx dx is now equal to minus x cos nx all over n plus 1 all over n into, if I integrate cos nx dx, remember the theory, first of all, differentiate the angle nx, I'm going to have n. So you simply have all over n, then integrate the trig function. If I integrate cos, I'm simply going to have sine. Pull back your angle nx. It's as simple as this. So integral of x sine nx dx is now equal to minus x cos nx all over n, okay, plus, this is sine nx all over n times n here gives us n all squared. So like I said earlier, this is just what? This integral without the limit minus pi to pi, and without this constant 1 over pi outside. So which means whenever we effect this limit and this constant, then that automatically becomes what? Bn. So we'll now find for Bn. Bn then is equal to integral from, okay, is equal to 1 all over pi integral from minus pi to pi x sine nx dx. Now, since we found this integral, we have to now effect this limit and what? This constant outside. So this is now equal to 1 all over pi into, this integral gives us minus x cos nx all over n plus sine nx all over n all squared. Now you effect the limits. limit is from minus pi to pi. So from minus pi down to pi, you have this. So Bn is equal to, just like I did previously, I'm going to be effectively delimit all at once. So this is now 1 all over pi into, I have x here. In place of x, you put in your limit, upper limit minus lower limit. But not forgetting there's a negative sign here. So you put it out first, minus, open a bracket. Now in place of x, upper limit is pi, minus lower limit is minus pi. So I have upper limit pi minus lower limit, which is minus pi, okay, times cos. So you have cos nx, x is there, so in place of x, upper limit is pi minus lower limit. So this becomes cos upper limit pi minus lower limit minus pi times n all over n, okay, plus sine, same thing, sine nx. In place of x, upper limit comes first, it becomes sine pi minus lower limit is minus pi, okay, append your n all over n all squared. All right, so I have this. So Bn is equal to 1 all over pi into, this is minus, not forgetting there's a negative sign here, okay. Take note, pi minus pi becomes pi plus pi cos, same thing, pi minus pi becomes pi plus pi. So I have cos pi plus pi times n all over n plus, similarly, this is sine pi plus pi times n all over n all squared. So Bn is now equal to 1 all over pi into, mind you, pi plus pi here is 2 pi. There's a negative sign after here, so it becomes minus 2 pi cos 2 pi n all over n, okay, plus, same thing here, I have sine pi plus pi, that becomes sine 2 pi n all over n squared. Okay, so I said earlier that in front of a trig function, pi appears as 180 degrees. That means 2 pi automatically becomes 2 times 180, which simply gives us 360 degrees. Okay, so this is now Bn equals 1 all over pi into, I have minus 2 pi cos, in place of 2 pi there becomes cos 360 n all over n plus sine, same thing, 360 n all over n squared. And this is equal to 1 all over pi into, mind you, cos 360 is equal to 1, okay, 1 times minus 2 pi becomes minus 2 pi all over n plus sine 360 is actually 0, so you have 0 divided by, and everything here becomes 0. Okay, so Bn is now equal to, I have 1 over pi outside here, 1 over pi multiplies minus 2 pi over n, this becomes minus 2 pi all over pi n. So pi can cancel pi from here. This simply means that Bn itself is equal to what? Minus 2 all over n. So the value of Bn is simply minus 2 all over n. So we can effect that here. Bn equals minus 2 all over n. Alright, so having found the value of a naught, an, and bn, we can now write the series. Remember this formula, f of x equals a naught over 2 plus summation from n equals to 1 down to infinity. So which means this value of n starts from 1 and approaches infinity. So you can choose maybe the values of n up to 3 to 4, because it's a series, it doesn't have an end. So let's start with an. So when n is equal to 1, when n equals 1, then we have that an, from what we've obtained, an give us 1 all over pi n squared. Then a1, because we are simply saying when n is equal to 1, let's put into this relationship for an. This becomes 1 all over pi. In place of n squared, there n is 1, it becomes 1 all squared, and this is equal to 1 all over pi times 1 square remains pi. So this simply means that a1 is equal to 1 all over pi. You can test up to 3 and stop, since it's a series that runs to infinity, doesn't have an end. Unless you're given a range. If you're asked to test from n equal to 4, 5, then you also consider all of that. So when n is equal to 2, when n is equal to 2, then this becomes now a2 is equal to, from the relationship, you have 1 all over pi. In place of n squared, n now is 2, it becomes 2 all squared. This is equal to 1 all over 2 squared is 4, so it becomes 4 pi. So this simply means that a2 is equal to 1 all over 4 pi. Okay, we keep that aside. When n is 3, we can stop it here. When n is 3, then a3 is equal to, again, 1 over, you have 1 all over pi. In place of n squared, n is 3 now, it becomes 3 all squared. So this is equal to 1 all over 3 squared is 9, so it becomes 9 pi. Alright, so this simply implies that a3 is actually 1 all over 9 pi. You keep this aside. So these are the constants, Fourier constants for what? An, from 1 down to 3. So let's test for bn. Let's test for bn. Again, when n is equal to 1, then you simply have that b1 is equal to, remember we obtain b1 as what? 2 minus 2 all over n. So this becomes minus 2 all over n is 1 now, it becomes minus 2 divided by 1. This simply implies that b1 is actually what? Minus 2, because minus 2 divided by 1 remains minus 2. When n is 2, when n is equal to 2, this becomes b2. Again, bn is minus 2 all over n. It becomes now minus 2. N now is 2, so minus 2 all over 2, which is equal to what? Minus 1. So this simply implies that b2 is actually what? Minus 1. Finally, when n is 3, when n is 3, then you have b3 to now be equal to, again, bn is what? Minus 2 all over n. It becomes minus 2 all over n is equal to 3 in this case, so it becomes minus 2 all over 3. Alright, so you can leave your answer like this for b3, or you can actually write in decimals. Alright, so you find the values of an and bn at the intervals of n from 1 down to 3. You can stop your limits. You can stop your series here and write them. So let's write the series and see. So the Fourier series of that function f of x, and f of x was given as x in the question. So the Fourier series of x is equal to, we said a naught all over 2. We look over now. What is a naught? We obtain 0 for a naught. So this is simply what? 0 divided by 2 plus, we said summation from n equal to 1 down to infinity, and we actually did from n equal to 1 down to 3. So let's start with an cos nx. When n is equal to 1, we obtain a1 to be equal to 1 all over pi. So this is now 1 all over pi. Remember, this is an cos nx, and n is equal to 1. So this becomes what? Cos. 1 times x remains x. So this is now a1 cos 1x. Okay. Plus, again, we considered when n is equal to 2, we found a n down to 3. So when n is equal to 2, a2 gave us what? We had it here as 1 all over 4 pi. Okay, so this becomes 1 divided by 4 pi, but remember it's always an cos nx. Now n is 2, so this becomes what? Cos 2x plus, we did up to 3. When n is equal to 3, we obtain a3 to be equal to 1 all over 9 pi. So this becomes 1 divided by 9 pi, again cos nx, n now is 3, so this becomes cos 3x plus, the series continues, plus we move over to the sine series, bn sine nx. We started from 1. When n is equal to 1, we had b1 to be equal to minus 2. So this automatically changes, becomes minus 2, again sine nx. N is equal to 1, so it becomes sine x, because 1 times x remains x. We move to when n is 2, we obtain b2 to be equal to minus 1. So this simply gives us minus 1 times, again, this is sine nx. N now is 2. It becomes 1 times sine, of course, remains sine. In place of n is 2, so this is now sine 2x. And finally, we consider when n is equal to 3, we have b3 to be minus 2 all over 3. So this is minus 2 all over 3. Now, sine nx, n now is 3. It becomes sine 3x plus, the series continues like that since it runs to infinity. So this is your final answer. You can leave your answer like this. This becomes the Fourier series of that function x. It's as simple as that, within the range from minus pi to pi. All right, so in general, all I've said is whenever a problem is given to you on Fourier series, the first thing to do is to what? Find the values of the Fourier constants, a0, an and bn. And of course, if you're able to do that, then you can find the since it's a series, you can choose a range of from n equal to 1 down to 3 or 4, depending on what the question is saying, and then you can solve. Now, if you look at this place, 0 over 2 is obviously 0, so you can you might want to take off this and write the series anyhow you want, excluding this, but you can still put it, doesn't matter, the answer still remains this. All right, guys, so in the next video I'll see you with couple of problems on Fourier series. Thanks and cheers.